Radian measures. Make sure that you have your calculator in front of you because you're going to need to use it today. So if you don't have it in front of you, pause the video and get it. All right, now that you have the calculator in front of you, I want you to go to the mode button and push the mode button. Your calculator should be in degree mode and degrees should be highlighted. But if you take a look at it, you also have radians that you could put the calculator in. And radians is just another measurement to actually measure angles in instead of degrees. All right, with that being said, keep your calculator in degree mode. Let's go on and see what it says here. The two most common units used to measure angles are degrees and radians. In trig, radians tends to be the unit of choice. A radian is the measure of the central angle that intercepts an arc that is equal in length to the radius of a circle as shown in the diagram to the left. 1 radian is approximately 1/6 of a rotation, or 57 degrees. We're going to learn how to actually convert from radians to degrees and then degrees to radians, actually using our calculator without changing the mode on the calculator. In order to go from radians to degrees, you multiply the number of radians by 180 over pi. Or a shortcut method would be to replace the pi with 180, because pi actually stands for 180 degrees. So pi means it's in radians, okay? And pi does not mean 3.14 yada 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 yada. In trig, it means 180 degrees. So when I see something like example number 1, pi over 2, okay, that's a radian measure because of the pi. If I wanted to convert it to degrees, I can replace the pi with 180 over 2, which means pi over 2 is 90 degrees. All right, so number 2 would be, if I wanted to convert that to degrees, it would be 3 times 180 divide by 4, and hopefully on the calculator you end up with 135 degrees. If you didn't get that, make sure that either if you want to put it in the calculator all at one time, you encase the whole top in a set of parentheses, or you go 3 times 180, enter, then divide by 4, enter. All right, let's move on to a couple more examples. 6 pi over 5. 6 pi over 5 would be 6 times 180 divide by 5. Put that in your calculator and see what you get. You're correct, 216 degrees. All right, try number 4 all by yourself. So hopefully you went 7 times 180 divide by 12, which should have given you 105 degrees. So we've learned how to convert from radians to degrees because as soon as we see pi, we know we're in radians measure, and we know that pi stands for 180 degrees. We're now going to go from degrees to radians. There's really no shortcut method here. We actually have to multiply the degree by pi over 180. All right, so let's do that for number 1. So 60 times pi over 180. So I'm going to put 60 over 1. I'm going to multiply. I'm going to get 60 pi over 180. 60 and 180 can be reduced by 60, so I'm going to get 1 pi over 3, or just pi over 3. So 60 degrees in radian measures is pi over 3. All right, let's go on to number 2. 45. We'll go 45 over 1 times pi over 180. So we have 45 pi over 180, which can be reduced to, let's see, 45 goes into 180 4 times, so it's pi over 4. So pi over 4 is 45 degrees. All right, pause the video, do 3 and 4, and come back and let's see how well you did. All right, hopefully for number 3, you multiplied it by pi over 180, and you ended up with 100 pi over 180. 100 over 180 can be reduced to 5/9, so it's going to be 5 pi over 9. For number 4, 300 over 1 times pi over 180. So 300 pi divided by 180. 300 divided by 180 on the calculator, math fraction, enter, comes out to be 5 pi over 3. Okay. One more example. If f of x is sine of x minus cosine of 2x, find f of pi over 2. Well, since our calculator's in degree mode, we're going to actually want to change pi over 2 to degrees. And we know pi stands for 180. So really it's 180 divided by 2, which is 90 degrees. So we're going to find the sine of 90 minus cosine of 2 times 90. So really we have the sine of 90 minus the cosine of 180 degrees. Let's put it in the calculator and see if we get an exact value, because it didn't say to the nearest whatever, so it's got to come out exact. And it does. It comes out to 2. Nice job. Now, if you didn't want to change pi over 2 to degrees to 90 degrees, you could have changed the mode on your calculator and then actually put in pi over 2. So if you change the mode on calc to radian, you could have put it in as sine of pi over 2 minus cosine of 2 times pi over 2. And if you do that, you would get the exact same answer. Okay, let's go on to the arc measure. To find the length of an arc, use the following formula. S equals theta times r. It's an important formula. S is the arc length. Theta is the central angle. But what you have to know about the central angle is that it has to be in radians. So the measure cannot be in degrees. It has to be in radians. And then r stands for the radius. All right, how do I know when to use this? Well, anytime in a question they say something about central angle and intercepted arc, you know you're using this formula. All right, so let's take a look at number 1. In a circle, a central angle, there's central angle, of 2 radians intercepts an arc, there's the arc, of 6 inches, find the length of the radius. So S equals theta times r. S in this case is 6. Theta in this case is 2 because it says it's 2 radians. I'm looking for the r. So I'm going to divide each side by 2. 3 is my radius. That's how easy this is. In a circle, the length of the radius is 4 centimeters. Find the length of the arc. There's the word arc. Intercepted by, there's the word central angle, whose measure is 1.5 radians. So we're going to use S equals theta times r. And this time we're looking for the S because they want us to find the actual arc. Theta is 1.5 and my radius is 4. So 1.5 times 4 comes out to be 6. Okay, let's do a couple more examples. Number 3, in a circle, the length of the radius is 6 meters. Find the length of the arc intercepted by the central angle, whose measure is 2 pi over 9. Well, we know that's definitely radians, even though they didn't say radians because it's got pi in it. All right, so we're going to do S equals theta times r. S equals 2 pi over 9 times 6. S equals 12 pi over 9. And they didn't ask me, I could either leave it like that or I could put it in the calculator and round it if I want, which comes out to be, I think, approximately 4.2. So either answer would be accepted. All right, in a circle whose radius measures 6 meters, a central angle intercepts the arc of 24 meters. Find the radian measure of the central angle. So S equals theta times r. S in this case is 24. I'm looking for the central angle, so theta is theta. And my r is 6. To get theta by itself, I'm going to divide each side by 6. 4 equals theta, or 4 radians, because theta has to be in radian measure. A pendulum makes an angle of 3 radians as its trip travels 18 feet. What is the length of the pendulum? Well, they didn't say anything about central angle. But if you think about it, the pendulum, when it swings, it makes an arc. So it really is an arc. And the pendulum itself, which is the arc, it says it travels 18 feet. So there's your arc. What is the length of the pendulum? The pendulum, which is swinging, would be your radius. So 3 radians is your central angle. So S equals theta times R. 18 equals 3R. Divide each side by 3. 6 is my radius, or the length of my pendulum. And I think that's the last question for today. So make sure that you have all your notes and bring them to class tomorrow if you have any questions. See you then.